In this video lesson, we will learn about completing the square. So first, I need to explain what completing the square is. So let's just take a function, let's say y equals x minus 3 all squared plus 3. This is a quadratic equation in vertex form. And we can expand it. For example, x minus 3 squared is equal to x minus 3 times x minus 3, and we can FOIL that. And then it'll become a quadratic equation in standard form. There's also a way of taking squares, such as x minus 3, this way. We just have x squared plus 2 times negative 3 times x plus negative 3 squared. Which when we simplify, we get x squared minus 6x plus 9. And what's important to remember is that we have both the x and the negative 3 squared, and then we also have 2 times their product. And I'll explain in a minute why this is useful. So we've used this to expand our original function into what we call the standard form of a quadratic equation. Completing the square is kind of the reverse. You start with what we call the standard form, and you end up with the vertex form. So again, completing the square is the reverse of what we just did. So let me show in an example how to complete the square. So remember, first, when we expanded the square, this is going to be our example. When we expanded the square, we ended up with 2 times both the things in the square. So we had an x and a negative 3. And this is going to become important. So if we have x squared minus 6x plus 2, the first step will be we divide negative 6 by 2. And we get negative 3. I'll explain why this is important later. Step 2 is we square this. We get negative 3 squared is equal to 9. And now what we do, the last important step to just remember is we rewrite our equation as follows: x squared minus 6x plus 9 minus 9 plus 2. Since plus 9 minus 9 is just equal to 0, it doesn't change anything. We have the same function. But what's important is how we're going to group this. And we're going to put the plus 9 with the x squared minus the 6x. And here we should recognize the square that we had before, the x minus 3 squared. Now this is why we divided by 2 in step 1 and then we squared in step 2. It's because we have 2 times negative 3 times x is negative 6x. But we multiplied by 2 there, if you remember when we expanded. And now we divide by 2. So let me show you. Yeah, and this, we started with standard form, and now we have vertex form, because we have our square, and then minus 7. And then it's minus 7 because negative 9 plus 2 is minus 7. And let me show you another example to make sure that you can do this on your own. Now this example will be a little bit more complicated. There will be one extra step, but it shouldn't be too hard. Let's take y equals 3x squared minus 6x plus 12. So this time notice, instead of just x squared, we have 3x squared. The trick is that we just want to, as the extra step, before we do anything else, we want to factor out the 3 from the equation. That is, we rewrite y equals 3 times x squared minus 2x plus 4. If we multiply back in the 3, we will get the same equation as we started with. But on the inside, we just have x squared with nothing multiplied times it. So now we apply the same steps to x squared minus 2x plus 4. We have negative 2x, so we divide negative 2 by 2. That's negative 1. Then, step 2, we square negative 1 and we get 1. Step 3, we rewrite this x squared minus 2x plus 4 as x squared minus 2x plus 1 minus 1 plus 4. Since it's plus 1 and minus 1, we have the same thing as what we started with, but we group it so that the plus 1 goes with the x squared and the minus 2x. And that's the perfect square, x minus 1 squared. Why? Because x minus 1 squared has an x squared, a negative 1 squared, which is a positive 1, and a 2 times negative 1 times an x, a negative 2x. And of course, negative 1 plus 4, the additional things afterwards is just 3. We plug this back in to our equation and get y equals 3 times x minus 1 squared plus 3. Now we just finish off by multiplying in the 3 again. We end up with 3 times x minus 1 squared plus 9, and this is in vertex form. I hope you found this video lecture useful. Thank you for watching.